Welcome, everyone. I'm excited to kick off this session with you. Today, we're diving into the world of Python with our first session, titled Introduction to Python. We'll explore what Python is, why it's so popular, and get a sneak peek into what you can expect to learn in this course. So let's get started and make this a fun and informative journey. Let's take a quick look at what we'll cover today. First, we'll go through the agenda to see the main topics. Then, we'll explore what Python actually is and why it was created, giving you some background on its origins. We'll also discuss the differences between programming and scripting languages to clarify where Python fits in. We'll look at the scope of Python, including who uses it today and what kinds of things you can do with it, which is really exciting. We'll also cover how to install Python and run code, making sure you're ready to get started. Additionally, we'll look at a sample code to see Python in action and understand what it can do. Throughout the presentation, I'll emphasize the key concepts and how they relate to the overall theme of understanding Python as a versatile and powerful tool. So, let's dive in. Let's take a quick overview of what we'll cover today. Our agenda starts with understanding what Python actually is. Then, we'll explore the scope of Python, where and how it's used. We'll look at the differences between programming languages and scripting languages to clarify its unique position. We'll also examine who uses Python today, which includes a wide range of industries and professionals. Next, I'll explain why so many people choose Python. Its simplicity, versatility, and strong community support make it a popular choice. We'll then see what you can do with Python, from web development to data analysis and beyond. Following that, we'll delve into the history of Python, how it was created, and how it has evolved over time. I'll also guide you through how to run Python, including installing the right IDE to get started. Finally, I'll share a sample code so you can see Python in action. Throughout this presentation, I want you to see how Python's flexibility and ease of use make it an invaluable tool in today's tech landscape. Let's talk about what Python actually is. Python is a versatile, general-purpose programming language, which means it can be used for a wide variety of tasks. It's often applied in scripting roles, helping automate repetitive tasks or process data efficiently. So, when we say Python is a programming language as well as a scripting language, we're highlighting its flexibility. You can use it to build complex applications or to write simple scripts to get things done quickly. Another key point is that Python is called an interpreted language. This means that Python code is executed line by line by an interpreter, rather than being compiled into machine code beforehand. This makes Python easy to test and modify, especially when you're starting out or working on projects that need quick iterations. Overall, understanding Python's dual nature as both a programming and scripting language, along with its interpretive approach, helps us appreciate why it's such a popular choice across many fields today. Now, let's look at the key differences between a program and a scripting language. First, when we talk about a program, we're referring to a sequence of instructions that is executed after being compiled. This means the source code is transformed into a form that the computer can run directly. Typically, a program is designed to perform a specific task, and once it's compiled, it can run independently. On the other hand, scripting is a bit different. Scripts are interpreted, not compiled in advance. This means the code is read and executed line by line at runtime. A script is written in a scripting language, which is actually a subset of programming languages. The main idea here is that scripting languages are often used to control or automate other software applications, making them very powerful for tasks like automation, customization, or quick development. So the core difference lies in how they run. Programs are usually compiled first, while scripts are interpreted on the fly. Both serve important roles, but understanding their execution methods helps us choose the right tool for the task at hand, especially as we explore various programming and scripting environments in this presentation. Let's take a quick look at the history of Python. It was actually invented in the Netherlands during the early 1990s by Guido van Rossum. Interestingly, Guido started working on Python back in December 1989, during the late 1980s. Now, one fun fact is that Guido was a big fan of a TV show called Monty Python's Flying Circus, which was very popular in the Netherlands. That's how the language got its name, Python. And an important point to remember is that from the very beginning, Python was open-sourced. This openness helped it grow rapidly and gain a strong community of users and developers. So, this history shows how a personal passion and open collaboration can lead to something truly impactful in the tech world. Let's talk about Python's benevolent dictator for life, or BDFL. Guido van Rossum, the creator of Python, described it as an experiment in balancing the amount of freedom programmers need. Now, what does that mean? Well, if you give programmers too much freedom, the code can become a tangled mess, hard to read and understand by others. On the other hand, if you limit too much, you risk stifling creativity and the expressiveness that makes Python so popular. The key here is finding that sweet spot, allowing enough flexibility for developers to be creative and efficient, but also maintaining clarity and readability. This balance is crucial because it directly impacts how easily teams can collaborate and maintain code over time. And to connect this to our overall theme, Python's success lies in this careful balance, giving developers the tools to be expressive while ensuring the code remains accessible. Guido's leadership has helped steer this philosophy, making Python a language that's both powerful and user-friendly. So, the main reason I created Python was because I saw a clear need for a higher-level programming language within the Amoeba operating systems project. At that time, developing system administration utilities in C was becoming quite time-consuming, and it was slowing down progress. I also realized that trying to do these tasks in the Bourne shell just wouldn't cut it for various technical reasons. There was this gap between the power of C and the simplicity of shell scripting, and I felt there was a real need for a language that could bridge that gap effectively. That's really the core motivation behind Python's creation, to make system programming and scripting more efficient and accessible. Let's take a closer look at the scope of Python across various domains. First, in science, Python has become a vital tool in bioinformatics, enabling researchers to analyze large datasets and develop complex algorithms with ease. Moving on to web application development, Python offers powerful options like CGI for server-side scripting and Jython, which allows us to use Python within Java environments, particularly for servlet-based applications. In system administration, Python proves its versatility by managing Unix systems, automating tasks, and streamlining workflows. It's also integrated into enterprise platforms like WebLogic and WebSphere, helping to automate deployment and management processes. Finally, Python is widely used for testing scripts, automating tests to ensure software quality and reliability. Overall, Python's flexibility and extensive ecosystem make it suitable for a broad range of applications, from scientific research to web development and system management. This versatility is a key reason why Python continues to grow in popularity across different fields. So, why do people use Python? Well, there are a few key factors that really stand out among users. First, Python is object-oriented, which means it supports important programming concepts like polymorphism, operation overloading, and even multiple inheritance. This makes it flexible and powerful for building complex applications. Another great feature is its use of indentation. This might seem simple, but it actually enforces a clean and readable code structure, which is one of Python's greatest strengths. It helps keep your code neat and easy to follow. And then, there's the fact that Python is completely free. You can download and install it without any cost, and the source code is easily accessible. This openness encourages a wide community of users and contributors, making Python even more versatile and constantly evolving. All these factors, its object-oriented nature, its emphasis on indentation, and its free accessibility, really highlight why Python is such a popular choice for developers around the world. So why do people choose Python? Well, first off, it's incredibly powerful. It offers dynamic typing, which means you don't have to specify data types explicitly, making coding more flexible and faster. Plus, it comes with a rich set of built-in types and tools that simplify many tasks. On top of that, there are numerous library utilities, including third-party options like Numeric, NumPy, and SciPy, which are great for scientific computing and data analysis. And because of its automatic memory management, you don't have to worry about handling memory manually, which can be a real-time saver. Next, Python is highly portable. It runs on almost every major platform out there. So, whether you're on Windows, Mac, Linux, or even some less common systems, as long as you have a compatible Python interpreter, your programs will work exactly the same way. This cross-platform consistency makes Python a practical choice for diverse environments. Another key advantage is that Python is very mixable. You can easily connect Python with components written in other languages. This is especially useful when you're dealing with computationally intensive problems. You can link Python to fast, compiled code to boost performance. In fact, Python and C integration is quite common, allowing you to combine the ease of Python with the speed of lower-level languages. Then there's how easy Python is to use. Unlike C or C++, you don't need to go through multiple compile and link steps. Python programs are automatically compiled into an intermediate form called bytecode, which the interpreter then executes. This process gives you the development speed of an interpreted language without sacrificing performance, making coding more efficient. Finally, Python is easy to learn. Its structure and syntax are intuitive and straightforward, so even beginners can pick it up quickly. This simplicity helps in focusing on solving problems rather than wrestling with complex syntax, which aligns perfectly with our theme of accessibility and efficiency in programming. Let's talk about installing Python. On most Unix systems, like Linux and Mac OS X, Python actually comes pre-installed, so you might not need to do much there. That's a big advantage because it saves time and effort. Now, if you're using a Windows operating system, you'll need to download Python yourself. You can do this easily from the official Python website. It's straightforward. Just head to the site, find the download link, and get the latest version. Currently, the most recent version is 3.4.1, but keep in mind that many users still prefer version 2.7.7, which is quite stable and widely used. After you download and run the installer for Python 2.7.7, the process is simple. Once installed, go to your Start menu, click on Python 2.7, and then select Python command line. When you open it, you'll see the prompt, which looks like 3 greater than signs. That's where you can start typing Python commands directly. This setup is important because it gets you ready to write and run Python code quickly, whether you're on Windows or another system. Remember, the key is to make sure Python is installed correctly so you can focus on learning and experimenting with your code. Let's take a look at who is using Python today. As you can see, Python isn't just a hobbyist's language. It's actively used in real, revenue-generating products by major companies. For example, Google relies heavily on Python in its web search system, and interestingly, they even employ Python's creator. That shows a lot about its importance in large-scale applications. Then there's ESRI, which uses Python as a tool for end-user customization in their popular GIS mapping products, so it's integral to geographic information systems. Moving on, companies like Intel, Cisco, Hewlett-Packard, Seagate, Qualcomm, and IBM use Python for hardware testing, which underscores its role in hardware development and testing processes. And perhaps most notably, YouTube, the world's largest video sharing platform, is largely written in Python. All these examples highlight how Python is embedded in various critical areas across technology and business. It really connects to our overall theme of how versatile and impactful Python has become in today's tech landscape. So, what can you actually do with Python? Well, it's incredibly versatile. You can dive into system programming, which means automating tasks or managing your operating system more efficiently. It's also great for component integration, allowing different software parts to work seamlessly together. If you're interested in creating graphical user interfaces, Python makes that accessible, so you can build user-friendly applications. For those working with data, database programming is a strong suit. enabling you to connect, query, and manipulate databases effortlessly. Internet scripting is another area where Python shines, perfect for web automation, data scraping, or even developing web applications. And beyond that, Python is widely used in gaming, image processing, working with XML files, robotics, and much more. The key takeaway here is that Python's flexibility opens doors across countless domains, making it a powerful tool whether you're developing software, automating tasks, or exploring creative projects. All right, let's take a look at this sample code. First, we assign the value 34-23 to the variable x. Remember, the slash indicates division, so this operation will evaluate to 11. Next, we have a comment, which is marked by the hash symbol, explaining that this line is just a comment and not executed. Then, we assign the string hello to y, and again, there's a comment noting this is another line of code. We also assign a decimal value 3.45 to z. Now the interesting part is the if statement. It checks whether z equals 3.45 or y equals hello. If either condition is true, which in this case they are, the code inside runs. We add 1 to x, so becomes 12. Then we concatenate world to y, turning it into hello world. This demonstrates string concatenation, which is a key concept when working with text data. Finally, we print the values of x, and why this code is a simple example of variable assignment, conditionals, string operations, and printing output, all fundamental building blocks in programming. Connecting this to our overall theme, understanding how to manipulate data and control flow is essential for developing effective programs. All right, let's talk about some key points to understand the code better. First, indentation really matters in Python because it indicates the structure of your code blocks, like loops or conditionals. Next, remember that assignment uses the equal sign equals, while comparison uses double equals equals equals. It's important to keep those straight. When it comes to logical operators, they're words, like and or not, rather than symbols, which makes the code a bit more readable. Also, the first time you assign a value to a variable, Python automatically creates it for you. You don't need to declare variable types explicitly. Python figures out the types on its own. For numbers, the basic arithmetic operators, plus, minus, multiply, divide, and modulus work as expected. But there are some special uses too, like using plus for string concatenation and % for string formatting, similar to C's printf. And finally, the main command to output information is print. It's straightforward and essential for displaying results or messages during your program's execution. All these points tie together to help you write clear, effective Python code that's easy to read and understand. Now let's take a closer look at how Python executes code. Python's traditional runtime execution model involves a couple of key steps. First, when you write your source code, which typically has the extension Python automatically compiles this into bytecode, which has the extension. This compilation process is happening behind the scenes, so you don't usually see it happening. Once the source code is compiled into bytecode, the Python virtual machine, or VM, takes over and runs this bytecode. It's like a virtual interpreter that executes the instructions. So, in a way, your code is both compiled and interpreted. It's automatically compiled into bytecode, then interpreted by the VM for execution. Understanding this flow is important because it highlights the efficiency of Python's execution process. Your source code is translated into a form that the VM can understand quickly, which helps Python deliver its flexibility and ease of use. This process ties into the overall theme of how Python balances ease of development with performance, making it a powerful language for many applications. Now that we've explored how to run Python, let's talk about what happens once you're inside the Python interpreter. You can type in commands at will, just like having a conversation with Python itself. For example, if I type print hello world, you'll see hello world appear on the next line. Notice that the output shows up without the prompt symbol, the. When you assign values to variables, like x equals 0, 1, 2, those quantities are stored in memory. However, by default, Python doesn't display the stored value immediately. If I want to see what's stored in x, I just type x, and Python will show the list 0, 1, 2. It's important to understand that only when a quantity is explicitly entered or called upon will Python display it. So, if I type 2 plus 3, it will perform the addition and show 5 right there. This behavior highlights how Python handles commands and outputs during an interactive session, making it a powerful tool for testing and exploring code on the fly. This interactive mode is really useful because it allows you to experiment quickly, see immediate results, and understand how different commands and data work together, all of which ties back into the overall theme of mastering Python for practical, real-time programming.